What math is used to predict a tsunami's path? Imagine standing on a beach watching the ocean. Now picture a giant wave forming out at sea, heading straight for you. How do scientists know where it will go and how big it will be? That's where math comes into play. Predicting a tsunami's path involves some pretty advanced math based on equations called partial differential equations. The main one used is called the shallow water equations. These equations are simplified versions of the Navier-Stokes equations, which describe how fluids move. They assume that vertical movements in the water are much smaller than horizontal movements, which makes sense for large ocean waves. Using these equations, scientists can model how a tsunami wave travels across the ocean. They look at how fast it moves, how high it gets, and which direction it heads. To solve these equations quickly and accurately, they use special numerical methods. These include finite difference methods, which approximate changes in the water by looking at small differences on a grid. Finite volume methods help conserve mass and momentum over tiny sections of the ocean. Finite element methods break the ocean into small pieces and solve the equations locally. There's also a mesh-free method called smoothed particle hydrodynamics, which models water as particles instead of a grid. All these methods need powerful computers because tsunami waves can travel at speeds up to around 450 miles per hour. That means warnings need to be issued fast, sometimes within minutes. The initial data used in these models comes from the earthquake that causes the tsunami. When an undersea earthquake happens, it shifts the sea floor. Scientists use a formula called the Okada solution to calculate how much the sea surface moves based on the fault's location, size, and angle. Once they have this initial deformation, they run simulations to see how the wave will spread. These simulations tell us when the wave will arrive, how high it might be, and which areas could be flooded. To speed things up, scientists create databases of different earthquake scenarios beforehand. When an earthquake occurs, they match the real data to these scenarios for a quick prediction. Modern systems also use artificial intelligence and deep learning. These tools analyze seismic and underwater acoustic data in real time. They help assess the earthquake's strength and the likelihood of a tsunami faster than ever before. This combination of math, computer power, and AI makes tsunami warning systems more reliable and faster, giving people precious time to evacuate and stay safe. So, the math behind these predictions is a mix of physics, clever algorithms, and smart technology working together to protect lives.